Hello, I am Vic Malyala. I am a Senior Vice President of Field Applications and Business Development here at Supermicro. I'm here to give a brief presentation about upping the performance ante while keeping the IT green from Supermicro's perspective. A quick background on Supermicro. We are founded in 1993 and we started with developing core logic for Intel x86 platforms at a motherboard level. And over a period of time, we have expanded our portfolio to cover a wide gamut of product line through the development of the motherboard, the chassis, the power supply, the BIOS, firmware, and the software management tools and service and everything bundled together to take care of customers of any size, starting from a small system integrator to a hyperscaler, an OEM customer, to somebody in the deploying systems at the edge. Being in Silicon Valley gives us the advantage of working with all the industry leaders and technology partners to bring the technology first to market. And that's been the core competence for Supermicro since the very beginning. And we do that by having so-called application optimized server building blocks, and by putting them together, which I will go in little detail later, to get the right value for the customers. Green computing is a very important initiative for Supermicro, and we are able to get that performance without compromise on anything while keeping the earth green or the compute green is what our initiative is. We are number 5th in the server vendor in terms of the volumes measured by IDC, and we did about 3.5 billion business last year, and that's about 1.2 million units that we shipped. And we have a strength of about 4,000 people. About 1,700 of them are engineering staff. And we take pride in providing the industry's broadest product portfolio, thus by addressing different workloads. And over a period of time, we've been investing in expanding Supermicro's presence worldwide. In terms of our manufacturing capabilities, our support and service infrastructure, as well as helping us to enable customers that are worldwide, whether they are in different geos or the multinational companies that have a need to be supported and supplied product worldwide. Fast forwarding to 2020, which is this year, we have the global expansion with headquarters in San Jose and our manufacturing facilities in Taiwan for the Asia Pacific operations and from Netherlands for the European operations. As I was mentioning, one of the key differentiators for Supermicro is a bottom-up approach. What we do is we look at the product design, and when we have to support a wide gamut of products through a vast product line, one of the ways is to do the building of all these components ground up under one roof, and we are able to put these things together to come up with the right combination for the customer for a given application. So for example, we have like few hundred motherboards and the enclosures and the power supplies to go with it. And if you think about the rest of the components that make the server on a hardware level, which is the riser cards, the add-on cards, the back planes, and heat sinks and whatnot, all those things put together, we can come up with thousands of combinations. And given a specific customer and what kind of problem that they are trying to solve, we will be able to put these things together with the right certification for a given region or if a given application. We'll be able to do that and get the right solution for the customers. This has been our success, and this has been our mantra. As I was mentioning, the expansion for Supermicro's thing came from initially their subsystems, then moved into servers, which basically some of them are quite famous. For example, the Twin technology, we were the first to bring to market back in 2007. And similarly, in several other areas, we are able to differentiate, bringing new technology and enable the customers with the right technology. And as it gets adopted, pretty much others also adopt the same. Today, the systems point of view, we are able to put them together in a rack level with the right solution, with software partners working with us to get the solution level deployment for the customers, including support and service. And one of the most important things is to build all these things based on open standards, which is where we try to take, whether it's the hardware or the software or the system management utilities, we try to make sure that our systems are designed keeping open standards in mind, as it becomes much easier for people to adopt these, and it's also compatible with what else is developed in the industry. That way, people don't necessarily need to have a vendor lock-in. If you take a look at some of the things that we have been doing, a part of it is also kind of connects with the open compute initiative. One of the things we have taken is majority of the customers are actually having a limitation in the amount of power per rack in a data center. They have restrictions around cooling. They have restrictions also in going with in dealing with very limited IT staff to customize or to make any experimentation on that. So if we are able to design platforms based on open standards, in this specific case, for example, Open Compute, one of the initiatives is the OCP 3.0 mezzanine for the networking connectivity, whether it's PCI Express Gen 3, Gen 4, or Gen 5. You can actually have that both backward and forward compatibility while giving people an opportunity to service them easily in the industry. So as the systems get deployed in a data center level, especially in a hyperscale or tier 2, tier 3 type of cloud service providers, it becomes important for them to be able to service it with minimal effort. People don't need to necessarily open up the boxes and then go with that. So that is one of the standards we adopted, in addition to having a standard PCI Express add-on cards. Similarly, when you take a look at system management side of it, one of the things that people have adopted is Redfish as an API. Good olden days, it was all about using a baseboard management controller and having an IPMI as a standard. But as the number of systems increase, we started to add these features, that way, whether it is Supermicro or some other vendor that is going to be supporting based on these open standards, people can manage the systems. Yet another initiative is OpenBMC, which actually is being heavily, I would say, asked for by tier 2, tier 3 CSPs in order to manage their system management and have their own particular tool set developed around it. These are all the open compute initiatives that we are taking and incorporating into the standard 19-inch rack form factor systems. And, case to point is we're talking about, how do we make these systems, available in volume, and how do we make it easy to deploy? How do we make it easy to manage, both in terms of hardware management as well as system updates and whatnot? Standardizing on the bill of materials is what we looked at. In case of a cloud DC product line, where we are supporting 2 of the OCP 3.0 mezzanine cards in the system in a dual socket type of platform, and the same thing can support certain add-on cards and have a very high efficient power supply. This is one of the things available in a 1U or a 2U type of form factor. So no bells and whistles, keep it simple and support the open standards, be able to go after different type of workloads within a specific data center. The other option is MegaDC. So one is about deploying standard workloads, and the second part of it is whether you want to have your own compute-intensive workloads, or you want to have something for your storage, big data analytics, or you want to have some VDI, or you want to have machine learning type of applications. These are all the different ones. And instead of having multiple different platforms with its own motherboards and other components, it makes it difficult for people to manage the inventory and be able to support and service them, especially for people who have deployments that are not necessarily centralized. In one place, if you have thousands and thousands of systems, it's relatively easy to manage them, versus people looking at deploying it in different areas, different regions that are geographically separated, and some could be in colo facilities and whatnot. How do we ensure that we are able to service them properly? So MegaDC is a product line where we kind of minimize this overlap. So the one motherboard is designed to take care of different form factor platforms, whether it's a 1U with NVMe, 1U with a lot of storage, like a 12 hard disk drives for and some NVMe drives for some Hadoop type of workloads, or a system with a lot of add-on cards, including a 2U form factor with some GPUs for VDI or machine learning type of applications, depending on which one you plug in. This way, what happens is that we are going to standardize on a single baseboard, so the qualification becomes easy, and if anything need to be serviced, it's much easier. Like with anything else, this is also going to support OCP 3.0 mezzanine card, as well as OpenBMC on this one. OCP 3.0 mezzanine is a standard, and Supermicro has an extension of that called AIOM, Advanced I/O module. What it does is, using the same connectivity and everything, we'll be able to work with the existing products available from different vendors, as well as what Supermicro can provide within the same form factor with some additional functionality. So if you take a look at something like this, we have a platform. This is based on Intel architecture with multiple OCP 3.0 mezzanine cards supported. And here you can see the size of these are actually a full 1U height, like a double stack per se for all the networking. In this case, we have more than 30 network controllers, which actually is used for edge aggregation of the data. At the same time, again, this is if someone were to swap any of these network modules, it becomes relatively easy because all of them are externally accessible, and these are based on OCP 3.0. Again, like with anything else, we are adding a lot of products, and we are developing a whole bunch of these different platforms to support these OCP mezzanine cards, whether it is a single 1 gigabit Ethernet going all the way to 100 gigabits Ethernet and beyond, depending on what the market would demand. So we are expanding the product portfolio to support all this. As we try to keep things green and efficient, which is what I started with, resource saving becomes an important factor. So in addition to having a system supporting very efficient power supplies and the cooling and other mechanisms to run it very efficiently over a period of time to reduce the operating expenses as a TCO, that is one side of it. The second part of it is how do we reduce the bill of materials and reuse any of it over a period of time. This is where the resource saving architecture comes into picture. So where we are able to use parts of the design. You don't necessarily need to upgrade or update the compute, storage, and networking all at the same time. We'll be able to separate it out, and based on our own needs and how the refresh of these components come in, we'll be able to refresh at that time. That's how we are able to reduce not necessarily the total cost of ownership, but what we call it as a total cost to environment. We'll be able to reduce the amount of toxic wastage that is going to be coming from dropping these systems once they are completed their life. What we have also seen is a heavy demand in supporting higher and higher wattage processors and as well as co-processors, whether it's GPUs or FPGAs or other type of accelerators. And in order to do that, in addition to what we are able to do in a forced air cooling environment, we are adding other things such as a different type of liquid cooling. In this case, we are able to look at the processors and as well as the co-processors and be able to provide a liquid cooling environment, direct chip level cooling, whether it is in a data center where they have chillers where you can have direct liquid cooling, or you could deploy it in data centers who have a need to basically manage them without any chillers. Means you have liquid to air type of cooling where you take basically the heat dissipation within the rack elsewhere. That way the systems will be operational. So this is something that we are investing quite a bit of resource to enable customers to take any kind of a workload and deploy it anywhere. As I was mentioning, part of it is for the AI and deep learning type of initiatives. There are heavy need for a lot of GPUs and different topologies that people are going to be using. So we have the platforms which support either from a single GPU all the way to 16 GPUs in a single node. And depending on what kind of applications, they may have a standalone GPUs versus something that is heavily meshed together, like using NVLink. 16 GPUs connected with NVSwitch and all that. So these are going to be supporting these initiatives. The storage is another very important factor, in which case people are looking at not just necessarily the capacity, but also the throughput and performance, whether it's latency, whether it is I/O and whatnot. Supermicro invests heavily and working with industry leaders such as Intel and several other technology partners in bringing either E1L or E1S for a small form factor versus a standard U.2 drives, which actually are quite prevalent in the industry, and we support all of them, including hot pluggability in many platforms in order to provide the right storage mix for customer applications. OpenBMC is one of the key initiatives that is driven by Open Compute standards, and we are supporting that. And as a part of it, we are working with several customers, and we are working closely with them, and also getting these certified and making it work with several platforms of Supermicro. As I mentioned, whether it's a Cloud DC or MegaDC, these are the platforms where we started initially working with OpenBMC project, because these are the ones we are expecting it to be populated in majority of the hyperscalers and tier 2, tier 3 cloud service providers, where all these people can benefit from the open compute initiatives. System management tools point of view, mainly we have a BMC, and in order to support systems out of band, especially when they're deployed in a massive scale, the easiest thing for us would be to actually work on, again, industry standards. Redfish API is what we support across the board, and people can use that and integrate into their own system management utilities. Currently, the Redfish version 1.8 is what we support, and we continue to enhance these tools as the customer demand arises. System management tools go further in order to provide security, which is one of the key pain points for many customers in industries. We are doing hardware root of trust on all these platforms, and we work with the BMC vendors as well as the technology vendors such as Intel, and incorporate that into that. So in addition to root of trust, the standard systems, whether you want to make sure the BIOS and firmware is signed and it's actually safe, and if something gets tampered, how do we make sure that we have a backup image which cannot be tampered with, and trusted platform module for people who are looking at incorporating security standards within that, enabling self-encrypting drives and things with respect to FIPS compliance and whatnot. So what we are trying to do is take the industry standard x86 architecture, incorporating into our platforms in a standard 19-inch rack mountable form factors, whether it's 1U going all the way to 10U, adding systems with the GPUs and the right amount of network and I/O mix, bring certain NVMe and high capacity storage to enable customer to size the platform right for the given applications with ISV certification, so people can use these systems in their data center, and while they do so, be able to save not just on the capital expenditure, but also on the operating expenses as they move forward, not across one, but multiple generations. With that, I'm going to conclude this presentation. And for any information, you can visit Supermicro website, supermicro.com, where you can get all the information about what we are doing with the latest technologies and what we are trying to bring it to all of you. Thank you.